Hello, and welcome to MECH-3409 Machine Element Design Final Gearbox Design video. This is made by Ayat Thabit, Mahgoub Mohammed, and Gary. There has been a need for people to be able to carry goods from one place to another, especially in their workplace. This has called for the need of more mobile good transport, and there are small units to carry goods for a short distance and can maneuver through pathways. The task for the students is to design a gearbox for transmitting power from a motor. These users can purchase the gearbox and use it in their vehicles. Also, companies which are willing to build their own transport carriages and transport people from one building to another can also use this type of gearbox. The students went through two concepts. Concept 1 had the gearbox connected to the using a V-belt and a pulley. The gearbox was installed on a half axle. Compounded gears would be used. Concept 2 had a gearbox connected to the motor using a coupling. The speed would go through some reductions to the output shaft of the gearbox. Then the power would be transferred to the axle using a spoked end chain. Now you can see concept 1 and 2 here on the video. Concept 2 was better since it was simple though concept 1 seemed like that of a differential gearbox, which is able to transfer power differently to the wheels, so each wheel gets its own power. It involves using a compounded gear train, which is complex to make on SolidWorks. We also used concept 2 because our objective tree needed low cost and ease of use. Also had durability, efficiency, and optimized dimensions. Now another thing is we went through a material selection process. The gearbox has 4 major components: the shaft, the gears, the housing, the bearings. The bearings are not manufactured, they're purchased. The material selection was done for the shaft, the gears, and the casting. The materials for the shaft, gears, and gears should have high tensile strength, high fracture stiffness, high strength, high fatigue, and the material needed to be ductile to allow for manufacturing. The following properties were inputted into the material selection program called CES, and the table below shows the properties of the materials that passed the selection criteria. We ended up using the materials that you can see in the next slide, which are shaft, low carbon steel, gears, ductile iron casting, gearbox, gray cast iron, and then the bearings were purchased. The shaft designed had a diameter of 30 millimeters and 55 millimeters for the first and second reduction stage. The life for the bearings was calculated. Each bearing on the first stage shaft had a life of 821,780 hours. The bearings on the shaft with the lowest speed had a life of 646,950 hours each. This was expected since the shafts with large torques should wear faster than those carrying small torques. Those are some dimensions of key terms. Now for the loads, the load comes from the power to the gearbox comes from a 12 horsepower motor that goes around 450 RPM. The loads that we used is the ends of the shaft were restrained. We used a torque of 189.9 Newton meters that is applied to the force section. An axial load of 150 newtons was applied as shown in the previous picture in the yellow region, and a downward force of 75% of the gearbox was which was 1889.375 newtons, which was equivalent to that of 75 of the applied force. The final design is as you can see in these pictures. In the final design, the overall length of the gearbox was 38 centimeters, which was below the essential maximum size of the gearbox. The mass of the gearbox is about 14 kilograms, which is also acceptable for the application.